Changing sea levels are threatening our coastal marsh and barrier island habitats, and currently the U.S. Army Corps of Engineers spends billions of dollars a year dredging and renourishing areas to help mitigate those effects. With that, we're seeing an increase in the number of Engineering with Nature projects, not only in coastal areas that are experiencing increased erosion due to sea level rise impacts, but also inland areas such as floodplain and riverine systems where flood risk reduction and resilient design concepts are just as critical. To assist with these trends, the use of remote sensing offers an opportunity to improve how we're quantifying and communicating project benefits. So collectively, remote sensing refers to a suite of technologies that encompasses everything from data collection and processing to analysis. Recent technological advances allow us to better map and characterize hundreds of square kilometers, but with project-relevant spatial detail. One project where we've successfully used remote sensing is the West Bay project. This combines U.S. Army Corps of Engineers navigation and ecosystem restoration missions. It's located in the Mississippi River Delta and utilizes innovative nature-based solutions.
Since about 1945 until the year 2000, West Bay, which is about 12,000 acres in size, lost nearly 8,000 acres of land to open water. This threatened the Federal Navigation Channel because we were losing the marshes behind the bank lines. When you lose the marshes, you threaten the bank lines. And when you threaten the bank lines, you threaten the Federal Navigation Channel. So the Army Corps of Engineers New Orleans District designed and built a diversionary channel that encouraged flow out of the main stem of the Mississippi River into West Bay, encouraging land building. Our New Orleans District also placed dredge material out of the Federal Navigation Channel into West Bay to help restore that land. The remote sensing data is instrumental to help us understand not only what worked, but how and why it worked. We wanted to document the land loss between 1945 and the year 2000. That was very important. But we also wanted to understand explicitly how the land gain happened between 2003, when the diversionary channel was built, and the present time.
Remote sensing was a valuable resource for rapidly extracting that information from aerial photography over the large spatial and temporal scale of the project. So the ability to visualize changes over time helps us to illustrate the dynamic processes that are transforming the landscape. For example, we used image analysis techniques to identify land and water habitat within the project area and to quantify the changes of that ratio over time. The ability to track changes over the life cycle of the project helps resource managers to evaluate the effectiveness of the restoration features as well as to quantify the environmental benefits.
So we had another Engineering with Nature project that was ideal for using remotely sensed data. The purpose of that project was to assess the movement and impact of dredge sediment that had been placed in a nearshore berm along the northern Chandeleur Islands in southeast Louisiana. The difficulty in monitoring places like the Chandeleur Islands are: one, the remote location of the island chain; two, the sheer distance or area that must be monitored; and three, the challenging conditions in which field researchers must operate. One of our objectives was to use remotely sensed data to assess when and where berm sediments were moving or being redistributed inside and outside of the island system. Another objective was to assess how those redistributed or moved sediments impacted vegetated features, whether it be existing features or newly created island features. We used LiDAR data that were collected from airplanes to assess changes in elevation, but also how sediments moved or were redistributed inside of the island system. Ultimately, we used these and other remote sensing data and methods to assess changes in island features pre-berm construction, post-berm construction, and after sediments were redistributed inside the island system.
Our overall goal is to improve the way we're integrating remote sensing approaches into the Engineering with Nature project portfolio. This is especially advantageous in areas where traditional field-based methods may be limited due to access constraints and making them difficult. Ultimately, we're looking to enhance project efficiencies through the use of updated remote sensing methods across the Engineering with Nature project lifecycle that are also broadly applicable to projects that share the goal of using natural and nature-based features all across the country.